Hello grade 5 6ers, welcome to our very first digital technology lesson. Today we have a fairly challenging lesson for you, especially as it's going to be our first time doing it online. But don't worry, I'm recording this on a video so you can watch it as many times as you need and pause it and play it whatever you'd like, okay? Furthermore, I'll also be online later for you guys to video chat with, so I can help you if you're getting stuck with it. Okay, now the lesson we're going to be learning today is going to be about binary. Now, binary is a computer language, and you may have seen it before. It actually looks like this, ones and zeros. Now, binary is how all computers communicate. Even your computer using right now, there are billions of ones and zeros telling it what to do. Now, binary only has ones and zeros. There are no number twos in it, okay? No number threes, no number fours, only zeros and ones. And with those zeros and ones, we can give computers all sorts of commands and instructions. Now, today we're going to be learning not the whole binary language, but we're going to be learning how to count in binary, okay? And to begin with that, we're going to have a look at how counting works in the first place. So I'm just going to switch over my screen here. And I have got on here just a little chart. Let's have a look at how our numbers work and how binary will work with it. Now, as you know, right now when we count, we would count just like normal, 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And once we hit number 9, we have no symbol for number 10. In our decimal system that we all use ever since we're in prep, we only have 10 symbols. Once we get to number 9, we have nothing after it. So we go back to 0 and put a 1 in front of it. Hence the number 10. And then we start counting again. 1, 1, 2, 3, 14, 15, 16, 17, 18, 19. Once I reach that 9, once again, I have nothing after a number 9. So we go back to 0 and add 1 more in the next column. 2. Okay? And eventually we'll get all the way up. We'll keep counting, look at that. Okay, there we go. 23, 24, 25, 26. Keep going all the way up until we get to number 99. Once we reach number 99, we have the same problem. We have no other numbers after it. So this 9 would change to 0 and we add 1 more in the next column. But we can't add 1 more in the next column because it's already a 9. So it turns to a 0 and then we add 1 in the next column and then we have 100. Okay? And eventually we keep counting until we get to 999. We follow the same rules. All right, this is a 9, we have to add 1 more, so it turns onto a 0 and we add 1 more in the next column. But we can't because it's a 9. So it turns into a 0 and we add 1 more in the next column. But we can't because it's also a 9. So it turns into 0 and we add 1 in the next column. And now we have 1,000, no hundreds, no tens, and no ones. And that's our number 1,000. Okay? As you guys know, this is our decimal system. Okay? You guys know it very well. You've been practicing it for many, many years. So we're going to try and teach you a whole new one in just 1 or 2 lessons. Binary is going to look different. I'm going to delete these and I'll show you. Okay, so in binary, we have 0 as the number 0. I'll put the decimal over here, all right? Decimal there. And 0 is still 0 because computers can count to 0 and 1, okay, by themselves. And then 1, just the same. But now in our decimal system, we would go to the number 2. In binary, we can't. There is nothing else after the number 1. There's no such thing as a 2 in binary. It goes 0, 1, and then there's nothing afterwards. So we have to go change this one to a 0 and put 1 in the next column. So this number 1, 0 is actually the same as our number 2. Okay? Now the reason binary can only go from 0 to 1 is actually because when computers were made, they're very stupid. They don't know much. So they've got lots of little parts in it, and something is either on or off. And 0 would stand for off, and 1 would stand for on. So that's why binary exists. It's just off, on, off, on. 0 is off, 1 is on. But never mind that. You guys don't need to know that. So let's keep counting and see what happens here. In the decimal number, after 2, we have 3. How do we write a 3 here? Well, so far we have 1, 0. Okay? We can add one more onto that easily. 0 just goes to 1. Excellent. And we just copy that one down because we just keep that the same. So the number 1, 1 is 3. Let's go to number 4. Okay, we have a 1 in that column already, and it can't go any higher, so it has to go to 0, and we add 1 to the next one. But we already have 1 in that, so it can't go any higher either. So we turn it into a 0 and add 1 to the next column. So the number 4 in binary is 1, 0, 0. Now, as you know, in decimal, we'd have ones, tens, hundreds, thousands, and so on. In binary, it's different. We have ones, then we have the twos, then we have the fours, then we have the eights, then we have the 16s, and then we have the 32s. Notice, see what the number's doing every time? It's doubling every time it doubles. 2, 4, 8, 16, 32. It's doubling each time. So this actually matches what we've got. When we had the number 1, 0, we had a 1 in the twos column, and that equals number 2. And down here now, we had, for the number 4, we have a 1 in the fours column. So that's 4. So this has a 1 in the fours, none in the twos, and none in the ones. So that's a total of 4. Okay? Let's keep counting. 5. Can we add more onto that 0? Yes, we can. So we just 0 goes to 1, and the rest stays the same as above it. Let's go to 6. Can we add more to that 1? No, we can't. So it turns into a 0, and we add 1 extra in the next column. So that 0 will turn into a 1. And then that one stays the same as above it. Number 7. Can we add more onto that 0? Yes, we can. 0 plus 1 equals 1. So that's fine. We can just keep those ones the same. Okay. Now we have the number 8. Now we've run up to this same problem before. Okay. We have a 1 in that column, a 1 in that column, and a 1 in that column for 7, because number 7 is 1, 1, 1. So can we add 1 more to that? No, we can't. So we turn it to a 0 and we go to the next column. Can we add the 1 to that column? No, we can't. So we turn it to a 0 and go to the next column. Can we add a 1 to this column? No, we can't. So we turn it to a 0 and go to the next column. So now we have the number 1, 0, 0, 0, and that is equals the number 8 in our decimal system. And as you'll notice, this 1 is now in the 8th column. 1, 8, 0, 4s, 0, 2s, and 0, 1s. And we have it. Okay, let's keep going a little bit further. We've got now here the number 9. Okay, Can we add one more to this number? Yes, we can. We can just turn that 0 into a 1. So we will. And the rest, we don't need to carry over anything else, so it'll all just stay the same. Now let's have a look at our sheet here again. The number 9 is 1001 in decimal. How can we check that to be sure? Well, we have a 1 in the 8ths column. See, there's a 1 in the 8ths column, none in the 4s, none in the 2s, but we have 1 in the 1s column. Okay? So we have 1 8 and 1 1. What's 8 plus 1? 9. And that's right, because this is representing the number 9, as you can see over here, just there. Okay. Now, at this point, you might be immensely confused. Don't worry. Normally in the classroom, I'd be able to walk around, wander around, help you guys, give you more examples and everything. So instead, what I'm going to do is I'm just going to ask you to try your best. Okay? If you get completely stuck and you just can't do it, give your best shot. You can ask your mum or dad for help if they're familiar with it. But look, if they're not, don't stress too much. Okay? We're not asking you to perform miracles. What I'm going to do instead is I'm just going to keep counting for a bit and you see if you can get the pattern. Already looking at my screen, you can probably start to see a pattern. Look at this ones column here. It goes 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Because it's the one column. It only spends 1 on each before it changes. Here's the 2s column. Look at this, the 2s has 1, 1 2 times. Then it has 0, 0 2 times. 1, 1, 0, 0. The 4s has nothing here, so it's all 0, 0, 0, 0. Then 1, 1, 1, 1. And then that'll be 0, 0, 0, 0 as well. Okay? And this 8ths one has 8 spaces before it comes in. Okay? You might notice those patterns and they might help you get an understanding of how binary works. Okay, I'm going to count a bit further, see how we go. 10. How do we do number 10? Can I add one more to that? No, I can't. So it turns into a 0 and I carry it over into the next column. And that, can I add one more to that? Yes, I can. So I do. And then the rest stay the same. So now I have 1 in the 8ths column and 1 in the 2s column. What's 8 plus 2? 10. Okay. 11. Can I add one more to that? Easily. Yes, I can. 0 just turns to 1. And that's done. So the rest just stays the same. Yeah. Stays the same. 12. Can I add one more to this? No, I can't. So I need to carry it over to the next column. Can I add one more to this? No, I can't, because there's no number 2s. Silly binary. Okay, so we turn it to a 0 and carry it over. Can I add one more to this one? Yes, I can. So I turn it into a 1 and just keep the rest the same. Now I've got a 1 in the 8 column and a 1 in the 4s column. See up the top here? 8 column and the 4s column. What's 8 plus 4? 12. That's the number 12. Let's go again. 13. Can I add 1 to that? Yes, I can. So the rest just stays the same. 0, 1, 1, same as above it. Number 14. Can I add 1 to this? No, I can't. So I turn it to a 0 and make a 1 on the next column. Okay. Then I just copy the rest of it along. Number 15. Can I add 1 more to this? Yes, I can. So 0 turns to 1, and then I have a 1, 1, 1, because those ones all stay the same. Now I've reached the number 16. 16 is another interesting one, because I can't add any more to any of this. It's 1, 1, 1, 1. There are no number 2s, which means we have to move it into the next column. So 1 can't change, can't get any higher. So we turn it back to 0 and we add 1 onto the next column. Can I add 1 to that? No, I can't. So it goes to a 0 to the next column. Can I add 1 to that? No. So it goes to a 0 and I go to the next column. Can I add 1 to that? No. So it turns into a 0 and goes to the next column again. So the number 16 is 1, 0, 0, 0, 0. And surely enough, as we look at the top here, we have a 1 in the 16 column. We have 1 16, no 8s, no 4s, no 2s, and no 1s, which means 1 16 is 1s. So number 1, 0, 0, 0, 0 equals 16. So boys and girls, I've got a little worksheet I want you guys to give a try in Google Classroom. Now it looks like this here. It's called decimal to binary. Now on this left-hand side, it's just going to have numbers down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth, all the way up to 20. 17, 18, 19, 20. On the right-hand side, I want you to have a go at putting the decimal number. Okay, remembering that the decimal number is how computers read that number. Okay? Now, the number 1 in decimal is 1. Easy. Have I got that all down? Yes. Number 2 in decimal, we can't go to number 2. Its binary is so stupid, we can't do it. So it has to turn back into a 0 with a 1 in front of it. So we have 1, 2, and 0 1s. That's number 2. Number 3, we add 1 more onto that. Can we add 1 more? Yes, we can, because that 0 can turn into a 1. Okay, because remember, it's the 1s column on the right-hand side. I might even put the little chart along there so you guys can see all the columns, if that's helpful. 1, 1 is the number 3. Number 4, I can't go any higher, so I need to put those 2 into zeros and put a 1 in front of it. So now I have 1 4, 0 2s, and 0 1s. So that equals number 4. Okay? Number 5, I can add 1 more onto it either, easily. 1 0 1. Now, boys and girls, feel free to use this one that I've just done on this video to help you do this, okay? This is a challenging task, especially when I'm not at your table with you to help you with it, okay? I want you to see how far you can count down in binary. Remember, just pause and rewind this video if you need help with some of those numbers, but I only went up to 16. See if you can go all the way to 20. Okay, but I can tell you now 20 is going to be very similar to what we've already done. There's going to be 1 16 and 1, is there going to be an 8 in it? No, 16 plus 8 would be 24. Have a look at that, have a think. I don't want to give away all the answers, so I want you to think about it. After you've counted as much as you can, down the bottom I have some decimal numbers and I want you to try and read them and write down what they are in decimal. So read these binary numbers, and write them down in decimal. So for example, the number 0, 0, so 0, 0 is nothing. You could even get rid of that. 1, 0, what's 1, 0? Well, what was 1, 0? 1, 0 is the number 2. Cool. So you could just write 2 there, and that's the correct answer for the first one. All right. I'm going to put up a little chart on here to help you out. I want you to give it your best shot. This is, like I said, a challenging exercise. I've even got a little video at the bottom of this as a little joke. Feel free to watch that, and it's relevant. You'll see what I mean. So boys and girls, yeah, give it a try. Have a chat to me later on online if you get really, really stuck. And don't stress too much if you can't quite get the hang of it. Just watch the video again, have a little practice, but don't stress about it, okay? There'll be lots more chance to work on it. This is just our first lesson. Thanks a lot for tuning in, boys and girls. I will talk to you all soon, and best of luck, and enjoy your working from home. See you next time, guys.